Alright, so this is my attempt to show Adam how to draw the Lewis structure for sodium borohydride. Sodium borohydride is an ionic compound with sodium being the cation and this polyatomic ion, which you may have not seen before, called borohydride, is the anion. What we're going to do is we're going to first draw the Lewis structure for borohydride, just like we draw any other Lewis structure. And then we'll put that in square brackets because it is an ion, and outside of that we will show the sodium cation, and that is the best we can do for a Lewis structure for an ionic compound such as sodium borohydride. Alright, so borohydride, first is BH4. Sodium, as you know, is +1, so there's the cation. And there's the anion. What we're going to do now is draw the Lewis structure for the borohydride polyatomic anion. First thing we do is we figure out how many valence electrons there are in borohydride. There are, let's do it over here. Boron comes with 3. Each hydrogen comes with 1. There's 4 of them. That's 7 plus 1 more for the negative charge is 8 valence electrons. So 8 electrons. Keep track of them from here. Boron has to go in the center, basically because hydrogen can't. So we put boron here, surround it with 4 hydrogens. Next, we connect the peripheral atoms to the central atom, subtract with single bonds, subtracting 2 valence electrons for each bond. 2, 4, 6, and 8. Well, we've used up all of our valence electrons, so let's check the octet rule. Each hydrogen sees 2, which is fine because that satisfies the octet rule for hydrogen. Now boron sees 2, 4, 6, 8. That's okay. Even though boron can be satisfied with 6, it's okay with 8 too. Formal charges, each hydrogen, 1 valence electron minus 1 line is 0 for each. For boron, 3 valence electrons minus 3 lines, 0 dots is -1. So we have a -1 formal charge here. The sum of the formal charges is -1 and the charge is -1. Okay, that's good. Let's erase this formal charge. So all we do is we put the borohydride polyatomic anion in square brackets, put the charge outside, and now we're going to take the sodium ion and put it in anywhere, over here, doesn't really matter. And there we go. That's the best we can do for a Lewis structure for the sodium borohydride, an ionic compound.